For the heart of this section, you're going to focus on identifying maximum and minimum of a given function using its graph. So the components of extrema are these right here. So let's go over each of them. Relative minimum is the least value of the function. Relative maximum, high value of the function. Now, absolute minimum is the lowest value. So what does that mean is if there are multiple relative minimum, there should be one absolute minimum, meaning among the multiple relative minimum, the lowest value of them all is absolute minimum. Now the same thing can say for absolute maximum, the greatest value. So if there are multiple relative maximum, the one that is the greatest value is the absolute maximum. Now the last part is called point of inflection. So a point of inflection is a point that is neither increasing or decreasing, but it is vertical or horizontal. So there are 5 components you would have to identify. Sometimes you might not be able to use all 5 components. Sometimes you can only identify just the absolute minimum, or just the absolute maximum, or maybe just the relative maximum, maybe even a point of inflection. So again, you may or may not use all 5 components when identifying maximum and minimum of a given graph. So for example 1, when we are identifying maximum and minimum using the given graph, I have marked 3 points where it changed from either increasing to decreasing or decreasing to increasing. So we don't have to worry about the ends or the arrows, just the point where a function changes directions from rising to falling or falling to rising. So again, 3 points. So let's take a look. I will start off with the middle one because there's only one at the bottom, or the lowest value. So that one is the minimum. So since there is only one lowest value or least value, that means it's going to be one minimum. So this will be classified as a relative minimum. So for relative minimum, I'm going to just write it right here. And what you have to write is just the coordinate point of it. So right here, the relative minimum, the coordinate point is 0, -3. So your x and your y. So my x is 0 and my y is -3. So that's all you have to do for relative minimum. So let's take a look at these 2 other points. Since there are multiple points right here, those are going to be classified as maximum, the high value or the greatest value. So since there's multiple, that means that there's going to be an absolute maximum. Well, in this case, neither one of them is higher than the other. They're actually both the same height or same level. So since there's more than one maximum, it's going to be classified as absolute instead of relative. So we're going to have 2 absolute maximum. So I'm going to write absolute absolute maximum. Alright, so absolute maximum. So, again, just the corner point. So over here, your x and your y. Corner point of this absolute maximum is -1, -2. So I'm going to write -1 and -2. So that's our corner point. And, you can just write a comma, or I'm just going to use the U symbol to be familiar. And I'm going to write the second corner point. So over here, 1 for x and -2 for y. So 1 and -2. So that's pretty much it. So the reason we use relative was because there's only one minimum. And the reason we use absolute was because there were two maxima. So same thing could be said if there were two minimums, then it would have been absolute minimum instead of relative. If there was one maximum, then it would have been relative maximum instead of absolute maximum. So our corner point for relative minimum is this, and the coordinate points for absolute maximum is this one, -1, -2, and 1 and -2. Ooh, oh man, oh man, oh man. Take a look at this graph for the second example. Alright, in this graph, there were 3 points marked. The minimum, the maximum, and here is the point of inflection. Now, keep in mind that point of inflection is a vertical or horizontal line. So here we can see it's a vertical line. And it doesn't change from increasing to decreasing, nor decreasing from increasing. Point of inflection is, if you can see, so if I go from left to right, it's rising, rising, rising. Oh, it's vertical, but it's continue rising, rising, rising. So that's going to be a point of inflection. Here, it is not, because it changed from rising to falling. This one, it is not a point of inflection, because it's falling and then changes to rising. So this will be a minimum, that will be a maximum, point of inflection. So it doesn't matter which order you're going to write. You can write from starting with the left or the right. But let's keep the process the same. So start from the left. So that's going to be our minimum. Since now I don't see any changes and it ends with the arrows, so I only see one minimum. So that means it's going to be a relative minimum. So I'm going to write right here, relative minimum. And the coordinate point for it is -1 for x, -5 for y. So -1 and -5. And there we go. Now next is the point of inflection. So I'm going to write it right here. Point of inflection. And just again, it's just the same thing, coordinate point. So x when it's 1, and then y for 0. So our coordinate point for point of inflection is 1, 0. Oops. And now our last one is the maximum. There's no more maximum, so it's just only one, meaning it's just a relative maximum. So, alright, relative maximum. Alright, so a coordinate point for our relative maximum is when x equals to 3, right there, y equals to 5. So our coordinate point for relative maximum is 3, 5. Let's see, 3, 5. Yep. So in this graph, you have a relative minimum at -1, -5. You have a point of inflection, 1, 0. And you have a relative maximum at 3, 5. So just like before, sometimes you might use all of them, or sometimes you only use certain components of maximum minimum. In this example, we have relative minimum, point of inflection, and relative maximum. The last example, you had absolute maximum and a relative minimum.